How's it going, everybody? This is Ron Sparkman from OpportunityU.com, and today we have a very special guest, Dr. Ulyana Horodyskyj. And I'm hoping I said that right. Every time I say it, I have a tendency to butcher it. So, Dr. Horodyskyj, how are you doing today?
Doing great. It would be better if I had some Skittles.
Well, we'll have to get into that in a moment and talk about your love of Skittles and where that came from, because one of her nicknames is Dr. Skittles. So that's an interesting story in and of itself. Do you want to give us your name with the flair? Because I know you like the flair.
Yeah, the flair would be Dr. Ulyana Horodyskyj.
Yes. And now you know my terror of trying to say that before starting an interview. So first up, Uli, let's talk about what inspired your love for space and exploration whenever you were younger.
Yeah, so I would say that my parents, they really inspired me. So I was actually homeschooled for a few years when I was really young. My parents took me and my two older brothers across Europe one summer. So they were really into hands-on education and immersion. And so at age 6 is when I saw my first mountains and glaciers. So I think I was kind of hooked from a very young age. Growing up, I was always tinkering with something or another in the kitchen or in a little lab that we created. My dad and I loved to work on science projects. And then also I had an awesome mentor in my early teens and throughout my teenage years who really helped me along when I started entering science fairs. So I think that early influence was really important, but I was also naturally curious, and my parents helped to foster that.
That's amazing. So what made you get into the field that you're in now? And it seems like you have specialties in about 6 different things. So what are your fields, and what got you interested in this particular in what you're doing now? Yeah,
so I mean, I specialized, I guess, in the earth sciences in college, focused on geochemistry, then went more the physics route in graduate school, and also planetary geology. So I'm just fueled by a love and curiosity for the world. I mean, that is that passion. And so I also love to climb, and I'm athletic. So being able to blend all of these interests into my career as a field geologist, I mean, it was just the perfect job for me.
Excellent. And you actually have started to utilize this in a different way. You're in some of the most desolate and freezing cold and high places. There's lack of oxygen, and you just kind of smile through all of it. And, you know, so it seems like there's so many people that seem to be confused about or even understand what climate change is and how we can improve it. And for you, this is a major part of your work. So can you give us a quick explanation of what a glaciologist is and how your work helps us understand climate change?
And also, don't mistake the smile. It's just my face is frozen that way most of the time in those.
That's what it looks like. Kind of frozen
so yeah, a glaciologist, that's a scientist who studies snow and ice, the formation and movement. So when snow falls at high elevations and it keeps snowing and compacts, then it turns into ice. And then that starts to flow downhill with gravity. And so you can consider a glacier this river of ice, albeit a really slow-moving river. But the reason I like glaciology also is it's interdisciplinary science. You have to use math, you have to use physics, chemistry, hydrology, which is the study of water, meteorology, which is the study of weather, and then, of course, climate. So what we're doing is studying the melting of these glaciers around the world. But mostly I've been sticking to the Himalaya, which is where I did my PhD and spent a really long time on a particular glacier up there. So basically temperatures are continuing to rise, and so glaciers are continuing to melt. In the Himalaya, we have a particular problem of these glaciers melting and creating glacial lakes. And they're expanding and deepening. And so that's presenting significant flooding hazards for the villagers there. You can also think of these glaciers as water storage towers in the mountains. So once melted, that water, unless we harness it somehow, it's gone. And so not only that, but like around the world, you also have Greenland and you have Antarctica, right? These are these big ice sheets. And the places that are on land, once that melts, that water is going to go into the ocean, causing sea levels to rise. That in turn is going to affect your coastal cities. So climate change is not a belief, it's a study. The study of it is science based on facts and evidence. And the evidence is overwhelming that we're changing this planet, and unfortunately not for the better.
And I think it's something that that most people have an idea about, that they're like, oh, well, I believe this, I believe that, and it's not really something of a belief. It's, you know, it's science is a method of study and investigation, and it's pretty much in. There are certainly people that have varying ideas on it. Of are we causing it? You know, is it just another is this just another time that the world's cycle is changing again? And they kind of have a tendency to argue that. And there's certainly things that, especially people like you do with drilling of ice cores, that kind of gives us a little bit more of an idea of what the Earth was like and how these climates have changed before. And that's really something that you're working hard on. And I know that actually you're really going to take what you've been doing out in the field and you're going to kind of put that into the classroom next year. So I know you're going to be doing a class about climate change. So could you tell us a little bit about what the class is going to be and where it's going to be and kind of what your focus is there?
So I'm really excited. It will be my first professorship, and it's an intro to global climate change down at Colorado College in Colorado Springs. It's mostly going to be freshman and sophomore level. And so I'm going to be teaching them, the facts of climate change and the evidence, towards it, but also want to teach them how do you learn how to read a scientific paper. Be skeptical, really think critically about how this research is being done. It's so valuable as a scientist to have that skill, to be able to look at these problems objectively. And so I think one of the most important skills that scientists can have is thinking critically. So that's really what I'm going to be stressing in the class. We're also going to be using the Science on a Sphere down at the Space Foundation, which is a great way for the students to be able to visualize in 3D how things are changing on a global scale. And then we're also going to be doing some local field work on Pikes Peak, digging some snow pits, taking snow samples, filtering them, looking for pollutants, because the more these fall on the surface of the snow, the more it can melt. So we're going to be looking at these localized impacts as well as global impacts in the class.
That sounds like a fantastic class. I might even have to skip over to another college to go take that. So when you talk about all this work, you're really kind of talking about things here on Earth, but a lot of the work that you have done has been focused even on things out in the solar system. And when most people would hear this, they might not necessarily think that you're very involved in the space industry, but you're really heavily involved in that arena, and it's something that's always inspired you. So one of those projects is Project Possum. So could you tell us a little bit about this scientist-astronaut program and your involvement in it over the years?
Yeah, so the Project Possum stands for Polar Suborbital Science in the Upper Mesosphere. It is a manned suborbital research and education program. That's devoted to the study of our upper atmosphere, and it's a role that it plays in the understanding of our global climate and how it's changing. So I've been really working at that ground level, but the impacts of climate change are being felt like 80 kilometers up as well. So basically with Project Possum, you're training as this citizen scientist candidate, scientist-astronaut candidate, learning how to operate, all of the high-end cameras and scientific equipment in order for eventually someday to go on a suborbital flight. I can't even say that word.
Suborbital.
Orbital.
It is a mouthful.
And so you're going to be taking scientific equipment there to collect samples, these particulates from the clouds, as well as temperature profiles at the edge of space. And not only are you helping out science, you're learning about yourself personally, how you react to hypoxia. They put you in a chamber and they take you from 0 to 20,000 feet within 10 minutes. So what are your symptoms? So if something happens in the spacecraft or to your space suit, do you know that you don't have enough oxygen and the crew members around you? So that's really, really important to train on. So we're also doing microgravity training. So that's that awesome vomit comet where you go up and down and you do the parabolas. You get maybe 20 or 30 seconds of microgravity at the top there. So you're just kind of floating around, and you're also testing the dexterity of these spacesuits. So there's a scientific purpose behind the fun flights. And then finally, there's aerobatic flight. And so you can go upside down and round in this airplane. And that's really to see how you handle and how your body handles the G's. Because when you do take off at suborbital flight, you're going to feel squashed. So you got to be able to fight that and make sure you don't pass out so you can actually do the science once you get up there.
That's kind of fascinating. So everything you do is boring. We just want to make sure we get that out of the way now. So Project Possum is one of the things you've been involved in. And most recently, you had the ability to command a Hera mission at NASA. So NASA in Houston, right? I just want to make sure. Okay. So that was a fascinating thing. It was isolation for over a month. So could you tell us a little bit about what is Hera? What is the Hera mission?
Yeah. So Hera stands for Human Exploration Research Analog, and it's basically simulating a deep space mission to an asteroid, and it's looking at the effects of isolation and confinement. And it's a crew of 4 of us. And really, I would say it's exploration of psychological effects and the effects of stress for being cooped up in essentially a tin can for those 30 days. But really, you're on task for about 7 weeks because you have to train before the mission, then you go into the mission, and then you debrief. And so when you're confined on this station, you have a lot of tasks you're doing, much like the astronauts on the International Space Station. And you're also working 16-hour days. So it's pretty tiring. And we actually have a cool mission patch I can show for our team. Let's see how that shows up on here. I can't see. So it has everyone's last names there. And then Hera 12, because we were mission 12 and we're the last of the 30 days. And now they're moving on to those 45-day missions, which are going to probably be a lot harder. It's tough because these are long working days. But I could say the food was good because that's actually left over also from what astronauts eat on the International Space Station. So that was really cool because you felt like, hey, I'm actually on station here and I'm eating the same food and I'm having to hydrate it, you know, and it's like being out in space.
That's pretty fantastic. I didn't realize that you guys were using the food that they're using on ISS. I actually just did an interview a couple of days ago talking about the journey to Mars with a NASA representative, and we talked about that, and, you know, just what the food's going to be like and how important it is. And you know, you mentioned the Space Foundation and what they're doing with SOS, and again, that was something that we mentioned. That's something that everybody's always interested in. What's the food like in space? Right.
And the thing that's interesting though is sometimes it's really spicy because when you're up in space and with all the fluid buildup, you can't taste as well. But down on Earth, that can get really spicy, depending.
So it's something that also you could certainly tell here, but you couldn't maybe tell as much up there. So that's pretty amazing. So what were some of the biggest challenges of the mission for you? So you know, that's a long time without the amenities that you may have been used to. You may be a little less so than everybody else since you spend so much time, you know, in the wilderness at the top of the world. But what were some of the biggest challenges for you?
I would say. So I was the pilot, so really learning how to fly the spacecraft in a way that I don't terrify the rest of my crew members. So that took a couple of weeks there. And then they also had us awake for about almost 40-hour stretch because we were going back home through a debris field, and we had to stay awake in case anything happened. So that was really challenging. And there's no coffee, so because you're on a fast, because they're taking blood also to look at, you know, biomarkers. The other thing is knowing that there's no sun and there's no weather. You know, I've been at altitude and on long expeditions, longer than this even before, but I've always had the elements. So it really just felt like the same day over and over again, except my clothes changed sometimes. So that was, and then also, you know, if something does happen and you get into an argument over whatnot, you know, because it's 30 days, you can't just walk out the door. It's space. So really learning how to deal with conflict resolution, I mean, and having patience. You know, you just learn so much about yourself and your crew members during it.
I can't even imagine, really. I mean, it's certainly something that I've thought about on more than one occasion. Even the hard sci-fi movies that you see or the books that you read kind of give you that idea of what isolation is really going to be like. But to live through it, even by choice to live through it and still be here on Earth, knowing that really on the other side, right there on the other side, is complete freedom. You know, that takes a special level of dedication. And speaking of dedicated, this is really something that you've kind of been working all these into your own thing, and that is science in the wild. And so exploration, being on the top of the world, and, you know, doing the science that's important and is really teaching us a lot is really kind of the focus of what you do. So you know, science in the wild, can you tell us a little bit about what inspired it, what is it, and you know, what you have coming up?
Yeah, so Science in the Wild, it was basically born out of this desire to continue to do science research in these remote and wild places on the planet. I mean, I spent so much time on the ground in Nepal, and I had volunteers helping me. So it's like, I want to take along everyday people to continue this and be able to experience it. Because I think you learn the most when you're exposed and immersed in these environments, and you're learning about the landscape. You're also interacting with the locals. You're hearing their stories of how the landscape's changing, their worries about adaptation. So I think it really brings climate change to life, as well as science to life. It's not this boring thing and you're wearing these lab coats. You're out there, you're wearing down jackets and balaclavas covering your face and your glasses, and you're out there doing science at the edge. And so essentially, I like to say it's also humanitarian and applied science, and it's by the people and it's for the people. It is a citizen science initiative.
And even during my trek last year, I mean, there wasn't anything that was basically scientific about it. It was just, you know, really kind of heading out. And even our guide, one of the main things he was talking about was how he has seen it change since he has been since he's grown up through the area, and just seeing the glaciers, the consistent avalanches, the different things that he's doing. He's even doing treks with younger people to take them out there to show them what it is that they're saving, and for people to do almost a sort of volunteerism. This thing that's kind of become a little bit bigger is for them to get out there and for you to take these people and show them, hey, here's the science of it. Here's what they're really seeing. So I know you've got a couple of big ones coming up. What are your next big events that you have?
Yeah, so we're gearing up in about 5 weeks now. First one is Aconcagua. It is the highest peak in the world outside the Himalaya, and that's in the Andes in Argentina. So we're going to be doing some interesting water quality studies, as well as sampling the snow as we go higher and higher on the mountain to look at the impacts of pollutants, if any. We don't know what is up there and how that compares with other mountain ranges like the Himalaya and some other studies I just did up in the Arctic. So that'll be really interesting. And then right after that, we will be going to Chile, the Atacama Desert, and Ojos del Salado, and that is the world's highest active volcano. And that kind of plays into my love of space, where it's going to be a Mars analog trip. We're going to be teaching people, if we were astronauts, we landed here, we know nothing about the terrain, what would we be able to say about the landscape? What are the skills we need as scientists? How do we even formulate questions? And what are the tools we have to study this terrain? So I'm really excited for that one. And we just paired up with a professor at CU Boulder to be able to collect rocks from the summit of the volcano to look for extremophiles, these bacteria that live in the rocks, really at almost, I think it's 7,000 meters. So it's just cresting over 23,000 feet, and there's bacteria living up there. So we're going to be bringing back those samples to the lab because that has implications for astrobiology and how life may survive or formed in other places in the solar system. So I'm really, really excited for that one. And we have a good group for that.
That sounds like it's going to be amazing. I was planning on going, but now I'm going to move my trip to the next one. But everything that you guys have been up to has really been incredible. And I know you're also working on doing some trips locally, maybe some through Colorado. But I know kind of generally more in the States that are going to be maybe more accessible to people that are kind of scared of saying, oh, I'm going to fly to the other side of the world so that way I can climb a mountain and do science. So what are some of the upcoming maybe local ideas that you guys are mulling over?
I was really thinking about that. It's really hard for people to take off that much time. And if they haven't had these kinds of experiences, what can I do to ease them into these kinds of bigger expeditions? And so thinking locally, Hawaii, for example. I know that's still far though, but Hawaii, that's a great analog. They also have high seas there where they had people living for a year pretending they're on Mars, for example. So that's a great one. You also have craters of the moon. So these are places where astronauts have trained in the past. So we can do 1 week excursions here to really learn about the geologic landscape, as well as, again, how we would study them as astronauts. And as far as local here in Colorado, we're looking to start up an After Dark series to do astrophotography as well as stargazing. And also robotics training, because we have these really cool underwater and surface robots that we use primarily in the Himalaya, but there's no reason we can't use them here and teach people how to actually pilot them and learn about their local neighborhood.
That's incredible. So if you're talking about somebody coming in and doing something a little bit more locally, maybe here in Colorado or in Hawaii, the gear probably isn't going to be as pricey. I know sometimes whenever you're traveling abroad, it can be, but this can kind of this is going to give people an idea of what it is that you do and see maybe if they want to take it to the next level. But if anybody's considering it, I highly recommend it. I've taken a couple trips in the last few years that have changed my life. I know that it's something that has certainly motivated the good doctor here to continue the work that she's doing. But on a completely separate note, I know that you have new T-shirts coming out. So what do the new T-shirts say?
No, this is the nice. This is just this.
that's the nice shirt, but I think the other one's going to be a bigger seller. Okay.
The other shirt is science with an exclamation point, because that's important. We do it in the wild.
I think that's wholly appropriate for the majority of people. I think that'll be just fine. I'm pretty excited about it. I can't wait to wear that to the Space Foundation one day and get a look like, what are you doing, Ron? So, so really, we got really one more question, and this is really kind of big. You're really an inspiration to a lot of people that follow you and watch what you're doing. It seems like you're kind of the real world version of Supergirl. You're everywhere. You're always doing something. So, what's your advice for those people that are passionate about science that that want to follow in your footsteps, and especially young girls and women in STEM?
Well, I do want to stress that, though, I did come from humble beginnings, that my family came over from Ukraine in the 40s, and we didn't have much growing up. So this was My parents were huge role models for me. They taught me about sacrifice as well as resilience, and these lessons I carried into life. Recognizing that grit is key in life, no matter what. And one of my favorite sayings is that dreams don't work unless you do, and it's absolutely true. It's important to work hard, but also work smart. Finding mentors, those who can guide you and really encourage you. And most of all, persisting, because payoffs can come up in the most unexpected of ways, and my life is a testament of that.
That's fantastic. And okay, so if people want to find you online on social media, website, can you give us some websites and Facebook, if you're on Instagram, Twitter, all that fun stuff?
Absolutely, yeah. So www.scienceinthewild is one phrase.com. Same thing, Facebook is just Science in the Wild. And we're actually going to be opening up a store selling these shirts. And this is a calendar that has some of our imagery from cold places on expedition. And the money is actually going into a scholarship fund. My first mentor was named Dr. Robert Forward. So in the spirit of paying it forward, I really want to create a scholarship fund for students. That's how I got my start. So proceeds from our shop are going towards those funds for students to come join us on these kinds of trips.
Awesome. Well, I'm so glad that I'm a student now. That just made me feel so much better about things. So we love it. Thank you so much. And if anybody is interested, we're going to drop the links below, so that way you can find Dr. Horodyskyj online, and you can find her on her Facebook page, social media, and all that fun stuff. So we really appreciate your time today. Thank you so very much. And we look forward to hearing about more of your adventures in the future. I'm sure that there will be plenty. So thank you so very much, Doctor.
Thank you so much.